TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that Thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our Sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that?
This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. there are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises two theories. One suggests that Baekdu was once two stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the two stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 107b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 107b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 107b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 107b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth, and its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated.
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up. Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blow-torched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called KOI 55b, or Kepler 70b. This planet is very far away from us, 4,000 light years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, KOI 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with KOI 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But KOI 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned KOI 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but two at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called super-Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler-69c, Kepler-1229b, and Kepler-395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next? A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more hype because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP 76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex. Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler-22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler-22b is similar to Earth's, It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet. Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away. And astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now no one can see what is going on. But this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars. And, as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this guy is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, This planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There is another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler 22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler 22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet. Earth. Home. The third blue rock from the Sun. The only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Corrosive Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and training. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on. But the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon. But scientists are already discussing moving to other planets to find a new home for humans. So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying toward you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. It's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful. gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
Now, space missions used to be this big deal, but now they're starting to feel like a walk in the park. But there's a catch. Our bodies aren't exactly built for surviving on other planets. Now, I know what you're thinking. Our bodies will eventually adapt and evolve, right? Well, yeah, evolution is always on the clock, but let's be real here. It's not going to happen overnight. We're not talking about a cool million years for some changes to kick in, and honestly, who's got the time for that? So, how about tweaking our genes just a little bit to make living on other planets easier? Genetic modifications are all about changing an organism's genetic material, like its DNA, to give it some cool new traits or characteristics. Now, picture this. Scientists could totally mess around with our genes to make us more resistant to crazy temperatures. You know, like the temperature fluctuations of the moon, minus 298 degrees Fahrenheit at night to 224 degrees Fahrenheit daytime. Wow. They might even figure out a way to make us super tough against radiation, which is a huge deal in space or on planets with weak atmospheres. We definitely don't want to get fried out there. Oh, and here's another thing they could do. Tackle the effects of low gravity. Spending too much time in low gravity can really mess up our muscles, bones, and even our heart. But if they tweak those genes related to muscle and bone growth, we could become super strong and resistant to all those nasty effects. However, it's not as simple as it might seem. The technology for safe and precise genetic modifications is still in its early stages, so it might even take as much time as it would for our bodies to naturally evolve and adapt to other planets. There are a couple of nice exoplanets where humanity might potentially live. I'm talking about Gliese 667cc, Kepler 442b, Kepler 62e, Kepler 452b, Gliese 837, you name it. In fact, I'm sure you can do a better job of naming than these. Now consider Gliese 667cc. In fact, let's nickname this one Gary for short. Turns out that Gary gets about 90% of the light that Earth does. But instead of regular visible light, this planet mostly gets infrared light. To put it simpler, Gary is rocking only 20% of the visible light that Earth gets. Yep, it's a bit darker over there. So, do we need really warm clothes and night vision goggles to thrive on this planet? Nah, not really. In addition to darkness, Gary is estimated to have a higher mass than Earth, meaning it likely has a stronger gravitational pull. To adapt, humans would need to hit the gym at least twice a day. Translation? Humans would need to develop stronger muscles and bones to withstand the increased gravity. Over generations, natural selection might favor individuals with these adaptations. We still know too little about these exoplanets to move there anytime soon. Hey, how about some planets in our solar system? Let's discover our top picks. This way, we can easily figure out what changes we need to make. So, first things first, let's eliminate the two ice giants in our solar system and their friends. Yep, Neptune, Uranus, and the two gas giants Saturn and Jupiter. Sorry guys, but terraforming you is just not gonna happen. Even so, we still have 4 super cool candidates right here in our solar system. You all know them well. Venus and Mars, the popular kids on the block. And then we have Jupiter's moon, Callisto, and Saturn's moon, Titan. They might not be as famous, but they've got some serious potential to become Earth 2.0. So, it turns out some of Jupiter's moons are super cool for terraforming. They're packed with water, which is a big plus. But here's the catch. Only Callisto is far enough from Jupiter's radiation belts. You see, on Earth, we get hit with about 0.24 rems of radiation per year. But, for instance, Ganymede, another of Jupiter's moons, gives away a whopping 8 rems per day. Just to make it clear, professional workers here on Earth can have more than 5 rem per year. Callisto is different though. We don't need to tweak our genes as it only gets about 0.01 rems per day, which we humans can totally handle. Now, let's not get too carried away with the idea that life on Callisto is all sunshine and beaches, like in California. Nope, it's more like an icy wonderland out there. So if you ever find yourself on Callisto, make sure to pack your snazziest protective clothing and some high-tech heating systems. Honestly, at this point, we might as well wish for evolution to take us back to our furry animal days. I mean, think about it. Our ancestors were rocking some serious fur game, just like those cool chimps and gorillas. But as time went on and we got all fancy with our evolution, we decided to ditch the fur coat and go for a more minimalist look. Now, why did we lose our fur? That's a question that has puzzled scientists for ages. Darwin thought it was about finding less hairy mates, while others believed it was to keep those pesky lice away. But these days, most researchers think it all comes down to staying cool. Picture this. Our ancestors were strutting their stuff on open, dry lands after they learned to walk on 2 legs. Think of a patchy forest or a sunny savanna instead of a lush rainforest. In that kind of environment, overheating was a real threat. So we evolved to have less body hair and more sweat glands to help us cool down by sweating like crazy. Now Titan, the moon of Saturn, is like a treasure chest of resources just waiting to be cracked open. We're talking hydrocarbon reserves that make Earth's look like a kid's play, with petroleum for days. Plus, it's got all sorts of organic compounds like methane, ammonia, and water. And don't forget its atmosphere is a nitrogen party, just like early Earth's. Here's where it gets really interesting. If Titan's atmosphere is similar to what Earth used to be, we could totally transform it into a modern Earth-like atmosphere. Picture this, giant mirrors in space beaming sunlight onto Titan's surface, heating things up and releasing water vapor. Oxygenated atmosphere coming right up. And to top it off, Titan hangs out within Saturn's magnetosphere, so it's shielded from those pesky solar winds. Now Titan's gravity is about 1/7 that of Earth, which could lead to muscle and bone deterioration over time. To counteract that, our bodies would need to develop stronger muscles and denser bones to withstand the lower gravity. Seems like Earth is the only place where we can't skip gym without gravitational consequences. Now, when it comes to being the hottest planet, Mercury may be the Sun's next-door neighbor, but Venus takes the crown. The temperature there is a scorching 870 degrees Fahrenheit on average. It's like trying to survive in a pot of boiling water or in the fiery depths of Venus itself. I guess the richest people out there would be those selling sunscreens and ice cream. Sorry folks, no amount of evolution can turn us into superhumans who can handle Venus's extreme conditions. The only beings that theoretically could possibly thrive there are tardigrades. These tiny cute little critters that look like caterpillars and have some seriously impressive toughness. They can survive boiling water, the darkest depths of the ocean, and even the freezing airless emptiness of space. In fact, they were part of a scientific study on a spacecraft that unfortunately crashed on the moon. Still, recent research proves that even these guys won't survive on Venus. Now, look at this guy. He's been kicking it on Mars for ages, which explains why he's rocking the wrong shade of self-tan. Turns out all those carrot-loving carotenoids in his diet, like sweet potatoes, bell peppers, tomatoes, and pumpkins, are the aces up his sleeve protecting him against UV rays. The more he munches on those, the more he turns into a walking orange. And let me tell you, his strength? It's all about that Martian gravity, my friend. The gravity there messes with our perception of weight. So if you want to be a boss on Mars, you gotta chow down big time. Like, if you weigh 150 pounds on Earth, it feels like you're carrying no more than 55 pounds on Mars. So overindulging in food can totally help bridge that gap between gravity and weight. Ooh, time to feast like a Martian.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios, more of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we'd definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. we're far from that. Generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable superwarm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry, even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the Rogue Planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday.